Okay, this video is going to look at two things that we talked a lot about when we talked about probability, which is two events being either independent or mutually exclusive, which are not the same thing, and it can be a little confusing to differentiate. So we'll do a couple examples of showing how we test for both. So this first one is the same table that was in the probability rules video. So first it asks, are driving an SUV and, being a male independent? So I'm concerned with these two events. So we need three probabilities to be able to answer this question. So first I need the probability of driving an SUV. So if I go to my table, there are 156 people that do that out of 240. So that's my probability. Then I need the probability of being male. So in this study, there are 60 males out of 240. And then finally, I need to know the probability of being both. So driving an SUV and being male. So here again, this is where I look for the overlap. So in this, this is all the different people that drive SUVs, and this is all the males. So they overlap at 21. So that probability is 21 out of 240. Okay, so the independence test says that if you take the two individual probabilities and multiply them, and it's equal to the probability of both, then it's independent. So we set this up. We're going to multiply the probability of driving an SUV and the probability of being male. And we're seeing, so you can even put a little question mark on top. So we're testing to see if that's equal to 27 out of 240. 21, I'm sorry. Okay, so you can go to your calculator and do this multiplication. I get exactly 0.1625. If I type 21 out of 240 into my calculator, I get 0.0875. Well, those are not equal. They're not even really that close. So really, this is not an equality statement. This is not equal. So then to answer this question, because they didn't come out the same, we say either that they're not independent or that they're dependent. That means the same thing. Or you can just say not independent. I'm just abbreviating because I don't have a ton of space. So that's how you test for independence. So you have to do a mathematical test to justify your answer. So the second question says, are driving an SUV and being male mutually exclusive? So mutually exclusive is the same thing as disjoint. Those are synonyms. That is just really asking, can they happen at the same time? Well, since there are 21 men in this study who drive SUVs, then certainly they can happen at the same time. So we say no, they can happen at the same time, something along those lines. So there's really no math that needs to be done here. It's sort of common sense, or you can just use what's in the table. Since there's no reason why a man can't drive an SUV, then they are not mutually exclusive. So that's an example of doing it from a table. Now let's look at it from, again, one of our favorites, just rolling a die. So same idea, we just, like before in that other video, you have to come up with the probabilities just by knowing how a die works. It's not laid out for you in a table. So at first it says, are rolling a 6 and rolling an odd number independent? So same process. Let's first find the probability of rolling a 6. Well, there's only one 6 on a die out of 6 different faces. And then the probability of rolling an odd. Well, 1, 3, and 5 are all odds, so 3 out of 6. Then my probability of both. So the probability of rolling a 6 and rolling an odd. Well, there is no way for those to both happen at the same time, so this is actually 0 out of 6, or you could just write 0 as well. Okay, so now I do my mathematical test again. If I do 1/6 times 3/6, I'm testing to see if that's equal to 0 out of 6. Well, since 1/6 times 3/6 as a fraction is 1/12, that is not equal. Since we know 0 out of 6 is just 0, those are not equal. So again, like last time, we would say either you can write dependent or not independent, because those two things did not come out equal. Okay, so then disjoint, I just used the other word this time, so same as mutually exclusive that we said before. Because rolling a 6 and rolling an odd, those cannot happen at the same time. 6 is an even number. So we would say in this case, yes, they cannot happen at the same time. And so those are two different examples of the difference between those terms.